Hi everyone, in this video I will go over all the questions of Fall 2021 Exam 2 for MA162. For 1, we have a integral of 1 over square root of 1 minus x squared and all that cubed. So since there is a difference of squares under square root, I'm going to choose to use trig sub here. And alright, let's draw a triangle. Say this angle is theta. Then I will have here 1 as it's a difference of squares, and then x will be here, so my sine theta would be x over 1, which is x, and then the third side would be square root of 1 minus x squared. So then dx will equal to cosine theta d theta. And cosine theta would equal to the square root part, right? So in this case, I can just sub that in for cosine theta for the square root part, and then dx for the d theta part, and rewrite. Just not gonna write the limit of integration now. I can sub x back in and still use those. So this would be 1 over cosine theta cubed be cosine theta d theta. So one of these will cancel out with the cosine theta outside. So we have then 1 over cosine squared theta, which would just be secant squared theta d theta. And this would be just simply tangent theta, right, plus c. And then I can sub it back in for tangent theta is simply x over the square root. So then now we have x over square root of 1 minus x squared evaluated over 0.5. So we will have 1/2 and square root of 1 minus 1/2 squared, and then minus 0 over 1, which is 0. So I'm gonna write it over here. So that's just 1/2 square root of 1 minus 1/4, which is 3/4. And what I can do is I can take out the 1/4 in the bottom as a 1/2 squared. So I have 1/2 root 3 at 1/2. So the 1/2 will cancel top bottom, and this will equal to 1 over root 3, which is d. For number 2, we have integral of a fraction, and this fraction, as we can see here, can actually be divided. The denominator can be divided into 2 parts, right? You can factor x out, be x times x squared plus 1. So this, I would say, the best approach would be partial fractions, as you have 2 parts, and this part would be like a non-factorable higher power. But before we do that, if you notice that the denominator power is cubed and also the numerator power is also cubed, that means we can use long division to simplify the numerator a little bit. So long division, I'll put denominator here, and then that's not a square root, just a division. Because plus 1. So 1 would fit for the cube going to the cube. Make sure I line up every power correctly. there's no x squared, and then there's just x. Right, then the remainder would be 3x squared plus x plus 1. And then I'll have a 1 outside. So what I have here now means that it's just the integral of 1 plus 3x squared plus x plus 1 over the factor form of that will be x times x squared plus 1 dx. Now, I'll do the partial fraction expansion over for this, which would be a x plus x squared plus 1 of b x plus c, right? It's a non-factorable, so I need to have bx plus c, and then all of this would be you would times x, right, this whole thing. Then also have the other side of the equation. I'm just multiplying both sides by the denominator. So this will cancel out. Whereas over the left side, the x will cancel out with the x, so I have a times x squared plus 1 plus the x squared plus 1 and the x squared plus 1 will cancel out, so I have bx plus c times x equal to 3x squared plus x plus 1. Then simplify even more. Bx squared plus cx equal to 3x squared plus x plus 1. And then I will have three unknowns in this situation where x is the changing variable. And then I'm gonna sort the different constants by their the x powers, right? So I'm gonna keep all the x squares together, all the x together, and all the constants together. So I have that should be a x squared plus bx squared equal to 3 x squared, and then the x squared can cancel out. For the x power, I have cx equal to x. So c will equal to 1, whereas a, the only constant term, will equal to 1, matching the only constant term here. So now I can plug a back into this first equation here, then b will equal to 2. That means that our partial fraction expansion, if I can move this, would be 1 over x plus 2x plus 1 of x squared plus 1. And then plugging back the other integral parts, right, that will be our expansion, right? And then I can split this into three different integrals. So first one, just x, right? Integral of 1 is just x plus ln x. And then I will have to do u sub for this. So let me just write it down. I can split this as 2 plus 1 over x squared plus 1. Right, in this case, for the first part of that, x squared plus 1 as denominator, I can use u sub. I can make the denominator equal to u, so then 2x would be du. So now I will have, so this becomes 1 over u du, then this will be just ln u, which is ln x squared plus 1. So that will be the first part of that, and then the second part of that is just tangent negative 1x. You should know that that should be one that's remembered. And then of course plus c for the indefinite. So we have x plus ln x, x plus ln x plus ln of 2x squared plus 1 plus tangent, so that should be b. For number 3, we have a typical trig integral. So what I want to do here is, since we have a tangent, I'm going to convert some tangent squared into secant squared. Right, in this case, we have tangent square x plus 1 equal to secant square x as our identity. Therefore, I can convert this to tangent x, and this would be secant x minus 1 dx. So simplifying or expanding that, we have tangent x secant x minus tangent x dx. So the first part, I can split this into two integrals, right? For the first part, I'll have u equal to tangent x, then du will be secant square x, or dx. So in that case, I will have u du, which in turn equals to 1/2 u squared. Carrying that back, I will have 1/2 tangent square x, and of course it's a plus c. All this, actually you don't need plus c since you have limits integration. 0 and pi over 3. And then, see, tangent of pi over 3 is, I don't remember, I just need to draw a triangle. So this, right, it would be 1, 2, and root 3, and this angle would be pi over 3, and then it would be just root 3. So root 3 squared, I will have 3 over 2, and tangent 0 is 0. Then for the other part, I have integral of tangent x dx. So this, I will split this so it's sine x over cosine x dx. From here, I can then use u sub with u equal to the denominator of cosine x, then du conveniently be negative sine x dx. In that case, I can replace the top part. So this, then in turn, it will be negative 1 over u du. So that will be negative ln u, and then I will plug x back in, be negative x, negative cos, negative, and then I can plug x back in for u, which will be negative ln cosine x. Evaluated from 0 to pi over 3. Now referring back to the triangle we have, cosine pi over 3 would be 1/2. So this would be negative ln 1/2. And then let's check the top. So we have the first part minus the second part. In that case, it would be the final answer would be 3/2 minus negative ln 1/2. Should be 3/2 plus ln 1/2. Now, if you check the answer, it's actually not one of our answers right now. What I can do instead is make so for the ln 1/2, right? It's actually ln 2 to negative 1. I can see it that way, as it's just the negative power, the inverse of 2, right? And then I can bring this this negative 1 power outside to be the constant outside the natural log. Then we have 3/2 minus ln 2. So that will be answer choice B. For number 4, we have a partial fraction decomposition, and if you look at our answers, we will see that it actually doesn't matter what that numerator values are. Those are all like A, B, C, D, F. So for those, we don't really need to worry about actually doing the decomposition. More so worry about what denominators we need to come up with. First of all, the denominator here, we first already have 2 parts, but this first part can also be factored into more simpler forms. So we can see that this actually, both of the polynomials in the first part has x cubed, so I'm going to take that out too, right? I don't care what's on the top. I'm just going to say, let's say just y. Some number is up top. And then taking out the x cubed, we have x squared plus 1. And then we also have the x minus 1 squared. Right, so we have here, so here is a repeated linear term and a repeated linear term. And here in the middle, we have a non-factorable higher power. So for repeated linear terms, we need to write every single one with a from the first power of the linear term all the way to the last power of the linear term. So in that case, we write x will have its own little fraction here, and then x squared, and then x cubed. Right? Each of the repeated linear terms gets its own, and so will the last part here, but that will be can be dealt with later on. But for the non-factorable higher power, that will have, since it only has one power outside, then we will have just dx plus e. Right, so that's just since there's a x squared on the bottom, right, we want to have one lower for this non-factorable term here, one lower power, that is. And then, of course, we have the last repeated linear term, EF plus the linear term repeated again. So these A, B, C, D all the way to F, G doesn't really matter, right? It's just really the denominators that matter, as they're just representing constants. So I'm just going to look for all the right denominators in the answers. Right, so we will have, right, this one doesn't have the x plus e part. Just got crossing out so it's easier to see. Right, this one has the x for the non-factorable, 2, 3 repeated, and then 2 more, so that would be f. For number 5, we have the integral from 0 to 1 of x squared e to the x cubed. So this is actually just a simple chain rule because you can see that the x squared can actually just be part of the chain rule that comes from if you take the derivative of ex cubed, then that will be 3x squared ex cubed, right? So this is just a chain rule. You can actually use u sub if you're not convinced, right? U equal to x squared, and then du equal to 3x squared, sorry, x cubed. So 3x squared dx, right? Then if we only want this part, then it's 1/3 du x squared dx, right? Replacing that, it will just be 1/3 e to the u du. So that would just be 1/3 e to the u, right? And then plug in the bounds and x. That would be 1/3 e to the x cubed over 0 and 1. So 1/3 have e to the 1 to cube, so just e, minus e to the 0, which is b 1. So then b will be our answer. For number 6, we have a integral of 1 over a square root. And I'm just going to investigate this complex expression under the square root. So right, I have x squared minus 6x plus 10. Right, from the first two, I can sort of complete the square where I can, if I can take a 9 out of the 10, right? If I have x squared minus 6x plus 9, so then I'm left with 1, right? And I will notice that this is actually a perfect square, right? It's x minus 3 squared plus 1, right? And this is the part under the square root, and this is also a sum of squares. So now I can use trig sub to solve this question, right? I can first make a u sub of u equal to x minus 3, then du will just be dx. So no need for changing dx there. Then I can have my integral being 1 over square root of u squared plus 1 du. Right, in that case, I can again draw a triangle. Since it's the sum of squares, I will have u, 1, and then the hypotenuse will be u squared plus 1. In this case, tangent theta would be u over 1, which would be u. So then du will equal to secant squared theta. And then I will have, that would be secant x. Secant theta would be 1 square root of u squared plus 1 over 1. Right, that would be hypotenuse over adjacent. Well, actually, you know what, that's fine. So in this case, I can trig sub all these in. So in that case, it will be 1 over secant x theta will be the just the integral part, and then du equals to secant square theta d theta. Right, in that case, secant square and one of the secant square and the secant will cancel out, which will be just left of secant theta d theta. And then this is one of the ones that maybe you should remember because this integral is a little bit complicated, but it comes out to be just ln tangent theta plus secant theta. And of course it's a plus c. So now we can just sub everything back in the way it came from. So secant theta would be the square root, and then tangent theta would be u. ln, that would be u plus the square root bit plus c. And then sub in back in x for u. We have x minus 3, right? That's the plus x minus 3 squared plus 1 plus c. And then that would be option D, right? If I just expand the x minus 3, then that would be option D. For number 7, we have a trough that's filled with a certain liquid, and we don't need to know what the liquid is since it's just giving us a rho for the liquid density and g that we can just use in the answer. And then that is in the shape given, and we're to find the force due to pressure, right? A way you can think about this is that well, you have a trough something like this. I'm looking at it sideways, or it might be like perpendicular too. But the water, or I'm just assuming it's water, it's a liquid. It has a force due to pressure going either way, right? So we are only interested in one end of the trough. And when we look at this one end, right, it's a triangle. Right, this is gonna have the pressure if I segment this uh, in the vertical way, right? I'm looking at this. Let's say this is y direction, and this is x. Um, right. So the hydrostatic pressure of like one layer, like let's say here, is the same as the same height, right? When the same height, that layer is the same, and that the hydrostatic pressure, let's say P here, will equal to rho gh, h as in how far it is from the top, right? Since it's the hydrostatic pressure comes from how much water is above that's pressing down on the water of that layer or liquid. I keep saying water. Uh, but so if we are able to, do this layer as dy, right, and then integrate over all that layers, then we can get that pressure over the whole area of this triangle. Um, and that's the approach I'm going to take, right? This pressure, or rather the force now, will just be the pressure integrated over dy. Pressure of a single layer. So where that single layer is, right, is just the y that I have, right? It would be 5 minus y, or I can just start y from the top, right? I can say y is going down this direction. Then this is 0 depth, and this is 5 meters depth. Right, keeping it at meters will be nice since the units will come out to be newtons, and that will be just SI units. So plugging in rho gh, in this case h will be y dy, and then I will have the integration from 0 to 5. Then rho and g are constants that can come outside, and I'm integrating over y, so just be a simple power chain rule. So that would be 0 to 5. So it would be rho g times 25 over 2 minus 0, and that would be answer A. For question A, we have a pretty classic trig integral question. For this question, we will see that, first of all, the cosine term has an odd power and the sine term has an even power. So I'm thinking ahead here. I'm thinking about what I'm u-subbing for this, right? The general strategy, since sine uh, has the even power, right? When I convert a lot of cosine of a lot of cosine squared over, sine still gonna have an even power, whereas the cosine will have a odd power of like cosine x, just odd power of 1. So in that case, I'm gonna u-sub for x, or u-sub for sine x. So it would be like u to the some power, whereas the du would just take away that cosine x, right? If I only have a cosine x of a single power, then that du would take that away. So that's generally what I'm looking for, right? I'm looking to convert all but one of the cosine x into sine x's. So let's write that, right? So I have cosine x and then cosine square x, and then sine square x, right? And then leaving that cosine square alone, I have 1 minus sine square x, 1 minus sine square x, right? Cosine square x just 1 minus sine square x. Then I can distribute out the last three terms, right? I still want to just keep the cosine x to itself. So I can distribute one of them at first, right? Then I'll have sine x minus sine to the fourth x, sine square x minus sine fourth x. Then again, I will have one, or rather, sine square x. That will be sine to the fourth x, and then 1 times negative will be then a minus again, sine to the fourth x, and then finally plus sine to the 6x dx. Now I can distribute these into three different integrals, right? With the same, or using the same u sub later on, but I'm just gonna make it simpler by just doing three. Cosine x, sine to the fourth x rather, dx, and then that'll be plus cosine x, sine to the 6. Right, each of these I'm gonna u sub now. Right, the cosine x it will be taken away, and then whatever the sine power is, right? Then it's u squared du minus u to the fourth du, or rather that should be 2. There should be a 2 here. I can leave that outside. And then plus, oh, and then plus u to the 6, right? That should be just chain rule. Minus 2 over 5 u to the 5th plus 1/7 u to the 7. Right, and I'm plugging sine x back in. Minus 2/5 sine to the 5th x plus 1/7 sine to the 7th x. And of course, you will need a plus c. So that will be our answer choice C here. For number 9, we have integral of actually three parts, right? X, sine x, and cosine x. And I've come up with somewhat of a creative solution, let me say. So I'm gonna use by parts for this, whereas I separate x for u. Right, for u, I have x. So then du would be just 1 dx. And then for v, I have sine x, cosine x, dx. Right, why did I do this? Or actually, this is du. For, first of all, from biparts we have Lyautier, whereas the algebraic of x will come first in the priority of u, choosing u, than the trig of sine and cosine. And the second is that I'm thinking that when I take the integral of this du bit, I'm actually able to use u sub and then to get that integral pretty simply. So let's get that. So I have u equal to sine x, then du will equal to just cosine x dx. Then to get that u, I would just take the integral of, it would be what? Sine x, cosine x dx, and then u sub it, I have u du. Then that would just be 1/2 u squared plus c. And then that would be 1/2 sine squared x. Right. I'm not too worried about the plus c since we have a definite integral. But I'm just there since we were solving sort of like a indefinite integral there. But so then we have 1/2 sine x. So now I'm gonna use u sub, right? This would be uv minus vdu. So now I can just plug in the v and u's. So I have, first of all, uv is x times 1/2 sine squared x minus, we have v 1/2 sine squared, and then du is just 1 times 1 dx. I'm gonna leave the first term for now and solve the integral. So we have 1/2 x squared, which you could use the half angle formula to solve. The half angle formula was sine squared theta equal to 1 minus cosine 2 theta over 2. I can sub that, which would be, I'm going to take 1/2 out of the integral first. It will be 1 minus cosine 2x over 2 dx. The first part, actually I'm going to solve it. So all of this is evaluated from power 4 and 0. So power 4, sine of power 4 is 1 over root 2. So the square of that will be 1/2 times 1/2 times pi over 2, power 4. So it'll be pi over 16. And then minus 0. And then I will have, and then I will have 1/2 of integral of 1/2. I'm going to split this into 2. And then power 16 minus 1/2 of this will be just 1/2 x. And then minus, where sine 2x. And then remember the chain rule, the half will be sine 2x over 4. And then all of this is evaluated from power 4 to 0. So power 16 minus 1/2 x will be 1/2 pi over 4, and all that will be pi over 16 plus, or it will be minus 0 first, and then plus 1/2 times sine 2x over 4. Sine 2x would be sine pi over 2, which would be 0. Which would be, sorry, 1. And then that would be, so sine 2x would be 1, divided by 4 divided by 1/2 would be 1/8. And then it would be sine 2x of 0 would be minus 0. So the final answer would just be F. For number 10, we have an improper integral with the bounds 2 to infinity. So we would need to replace that with a limit, right? So limit, let's just take a b to infinity and 2. So it will be, the limits will be 2 to b now, and then it's just 1 over x dx. Right, this integral is quite simple. Keep the limits still there. Right, this would just be ln x from 2 to b. Right, and then evaluating this would be ln b minus ln 2. Right, and then we can see that when we plug in this this infinity into ln, right, if we just draw a graph of ln, right, it's actually going to approach infinity as the x value approaches infinity, while we're also approaching infinity. So we have infinity minus like a ln2, which has no impact, right? And so this will actually just diverge because it has infinity as the value. So choose choice E here. Question 11, we need to find the first 4 terms of a sequence's partial sum. So for this, I would just recommend, for these type of questions, I would just recommend just writing them out, because it's just the only first 4. So you can just uh, write out the terms of the sequence and then sum the partial sums together. Right? So first 4 terms, I only need the first 4, right? Starting from k to 1, right? -1 to k of 1 is just -1, and then it will be -1 squared, which is 1, and -1 again, so it will oscillate between -1 and 1, and this is the sequence, right? And then the partial sum, then that will have, right, the first one is just the first term, and then the second partial sum would be the term the sum of the first 2, right? And then the first 3, right, it will oscillate between -1 and 0. So that will be just A here. For question 12, we're given 6 different sequences, and we need to find which one produces a, the third term will be -3. So similar to question 11, I will also just list these things, list the whole sequence out to the third term and see if it actually reaches there. All right, and starting from A, if our first term is 1, and the second term is 1 minus the last term, right? 1 minus 2 times the last term will be 1 minus 2 times -1, or 1 minus 2 times 1 will be -1, and then the third term would be 1 minus 2 times -1, which would be just 1, right? It will just oscillate between 1 and -1 and going on. So this is not it because the third term is not -3. For B, right, first term is 1, but then you just take the the negative that, and then the negative that. So that's the same as A. So it's not it. C, starting from -5, and then we just add 1 to each term, right? So -4, -3. So this then would result in the third term of the sequence being -3. Thank you for watching this video. The past exam archive and all the videos I did related to this exam will be linked in the description below. Please check them out if you're interested. Thank you.